Hello, how are you? Alright. Until last time we talked about union event and addition rule. Okay. So adding more. Addition rule for mutual exclusive event. Okay. So joint probability. First of all, addition rule will be, for example, like PA union P equal PA plus PB probability, subtract probability A intersection D, okay, or joint probability. So joint probability to mutual exclusive event AB is 0, which means that part is 0. One more time. That means so mutual exclusive two event, nothing common, just going 0. So joint probability is 0. That means that. So if we're asking probability union of two mutual exclusive event given by only sum of their marginal probability, which means the only marginal probability, no joint probability, okay? Only marginal probability. If you mutually exclusive, okay? Alright, apply this new problem. So union of two mutual exclusive event problems. So here the university proposes a student must take one course required for graduation. So 300 faculty and student university asking about the opinion. So they make a table here. So 300 total, faculty 30 and 70, and student 230. So question is randomly select person from 300 people, faculty and student. So favor or neutral, which means they asking question of a favor and neutral, like that. So let's say F is favor and N is neutral. So the question is a union of F and A. It's a union of that. So F or mean union, F probability F, probability N, and probability F and N. Okay. But here two number, which means one. First of all, probability for favor 135 of 300, right? And neutral 40 over 300. Okay. How about this? And so favor conditional neutral in like given, which means in favor. So nothing common, which means going to 0. So how it looks like that. So favor neutral, nothing common, nothing, which means this part going to 0, this part going to 0. So they're counting only marginal part, probability of marginal. Joint probability is going to 0. So we say that if two events mutually exclusive, because question is one person select can either favor or neutral, not both. Should do one. That's why. Okay, this mutually exclusive, choose only one part. One not common. Alright, one more example. Now we talk about 3 mutually exclusive question. So dice twice, right? Dice twice 1 to 6 number, right? So sum of numbers obtain 5, 7, 10. Two number. For example, 10 maybe 4 and 6, 5, 5 and 6, 4. Make 4 and make 10, right? Sum of two number anyway. So only 3 case. Okay. So we define the each one. A define event. A sum is 5. B sum is 7. C is sum is 10. Okay, 3 event. So union of A, B, C is like A or B or C. So like separately. Looks like no join. Okay, no join probability. Why? look at the figure picture here. So this is only 4, 5, right? This is only 4, 7. This is only 4, 10. Looks like nothing common, right? No joint probability, only marginal probability, like that. So 4, right? It's sorry, yeah. This total number is 4, total number is 6, total number 3. So how many here? 4 out of 36, 6 out of 36, 3 out of 36. Probability 0.361. Okay. So this one is 3 event mutually exclusive. Okay. That's why we don't need joint probability part. Okay. One more. Last question. So same thing. Union 3 mutually exclusive event question. So person favor genetic engineering about 0.55, or somebody favor someone against about 0.45. So two person randomly select the observer whether they favor opposite genetic engineering, opposite or against the same. So there are two questions. First of all, drawing tree diagram. You know, tree diagram looks like that, right? And probability, at least one of two person favor general engineering. At least one means one person or two person. At least one. Okay, that's question. So event define that F favor A against. So first question, A tree diagram, two person. First person choose favor against, and second person maybe choose again favor against two, like this way. First person choose favor against, second person also favor against. But they asking second question on at least one, so can be 2, 1, 1 is nothing, so it will be FF, FA, AF, right? So one person will be that way. Okay, so probability, each of them, this number, that number, that number. If you understand tree diagram, just apply here. Why if we want one subtract most here, right? So except nobody taking, no one taking, right? None, right? So it will be 1 minus 0.2025, return 7975, something like that. Okay, so you should understand tree diagram, also Venn diagram we already mentioned, and you should know how to do it. So mutual exclusive kind of a simple question, right, if you understand. Alright, looks like we'll be done chapter 4. Alright, maybe we can move on next time. So I'm gonna upload the homework too. Alright, okay, see you next time. Bye bye.